So in this video, we're looking at examples 1 through 3. With example 1, we're asked to simplify expressions in which we're looking at a power to a power. We're looking at an exponent to an exponent. And in those cases, remember when we're multiplying bases with different exponents, same base, different exponents, we add the exponents. When we're dividing same base, different exponents, we subtract the exponent on top by the exponent on the bottom. Now when we're taking a power to a power, we multiply the exponents. So with example 1, number 1, we're given 3 squared squared. Now we could do this one of a couple ways. We could go ahead and simplify what's inside the parentheses first, but that defeats the point of what we're trying to view, and that's we take an exponent to an exponent. So this is 3 squared, which would be 2 times 2, since we're taking it to another power of 2. And that equals 3 to the 4th. And again, perfectly acceptable answer if we're not asked for an actual numerical value. But we could go ahead and multiply that out as well. 3 to the 4th equals 3 times 3 is 9 times 3 is 27 times 3 is 81. Number 2 gets a little bit more complicated. Let's do what's inside the brackets first. So this is going to equal 4 cubed squared is going to be 4 to the 3 times 2. And again, that's still squared, which equals 4 to the 6th squared. And we're just going to multiply the inside exponent by the outside exponent. So that equals 4 to the 12th, the 6 times 2. And if we wanted to simplify further, this is a big number, but you could put it in your calculator. 4 to the 12th is going to be 16,777,216. With number 3 of example 1, we're given a variable that's taken to exponents, b to the 7th to the 6th. So again, instead of adding the exponents, we're going to multiply the exponents because we're taking an exponent to an exponent. So this is the same as b to the 7 times 6, which equals b to the 42. Now with example 2, we're looking at the power of a product. And the book doesn't really technically explain it this way, but how I like to explain it is essentially when we have nothing but multiplication inside the parentheses, which is the case with every one of these problems, we can distribute the exponent. So this is the same as, so negative 3x squared y cubed to the 4th power is the same thing as negative 3 to the 4th power times x squared to the 4th power times y cubed to the 4th power. And we can simplify the numerical value. Negative 3 times negative 3 is 9, times negative 3 is negative 27, times negative 3 is just going to be 81. That's negative 3 to the 4th. And again, when we have the other terms where it's a value being taken to a power and then everything being taken to another power, we multiply the exponents. So x squared to the 4th is the same thing as x to the 2 times 4, which is x to the 8th. And then y cubed to the 4th is the same thing as y to the 3 times 4, which is y to the 12th. Same thing with the second problem. 8b squared cubed is the same thing as 8 cubed times b squared cubed, which equals 8 times 8 is 64, times 8 is 256. And then b squared cubed is the same thing as b to the 2 times 3, since we're taking an exponent to an exponent, which equals b to the 6th. 5x to the 5th squared, that's the same thing as 5 squared times x to the 5th squared, which equals 25. And then x to the 5th squared is the same thing as x to the 5 times 2, which is x to the 10th. Now with example 3, we're given the problem the edge of each face of a cube is given by 3x squared y cubed feet. And what it's saying is that each one of these edges is 3x squared y cubed feet. And then it says to determine a simplified expression for the volume of the cube. So volume of a cubed equals the length of each edge, which we'll call S for side, cubed. Length times width times height, but with a cube, the length, width, and height are all the same. So we'll call it S cubed. So if each one of them, let's substitute, because this is S. So let's substitute 3x squared y cubed, and we're cubing that. And then again, we can go ahead and apply that exponent to each one of the terms that's being multiplied. And again, don't confuse this with if we were adding inside the parentheses. It's only when we're multiplying and dividing and or dividing only, not when addition and subtraction are involved. So in this case, this is the same thing as 3 cubed times x squared cubed times y cubed cubed. 3 cubed is 27. X squared cubed is x to the 2 times 3, which is x to the 6th. And then y cubed cubed is y to the 3 times 3, which is y to the 9th. And let's not forget our units. The length was in feet, so the volume will be in cubic feet.